Use vertical compression to make a piecewise function continuous. I really like this problem we had recently on a calculus test because the problem represents a bridge between pre-calculus, what we're studying now, graphical transformations, and what we've recently studied in calculus, which is principle of limits. The problem: find the value or values of k that will make the following function continuous everywhere. And we have here the piecewise function g of x equals negative x plus 9 when x is less than 3, and kx squared plus 1 when x is greater than or equal to 3. As far as continuous everywhere, well, these pieces in and of themselves, negative x plus 9 and kx squared plus 1, are both, no matter what k is, polynomial pieces of functions, meaning that respectively their domains are all real numbers. And so a continuity problem is not going to occur within either of these two pieces. But the point of importance here, the value of importance, is here where x equals 3, because this is where, at x equals 3, these two pieces need to be joined to make this piecewise function itself continuous everywhere. And in order to have continuity, three things have to occur. First, the function has to exist. And here, because we have x is greater than or equal to 3, our function is going to exist no matter what the value of k is, because g of 3 will be defined. Secondly, the limit has to exist. And for the limit to exist, the limit from the left side is going to have to join up to the piece from the right side for limit to exist. And finally, the limit of the function has to equal what the value of the function is. In this case, we say g of 3. So the limit, x goes to 3, of g of x, in this case, is going to have to equal g of 3. So that's analytically what we're looking at. Now, let's go to a graph to see what we're looking at right here. We have the two pieces graphed here. We have in blue f of x equals negative x plus 9, and here we have x equals 3. And from the left, negative x plus 9 comes like this, all the way to where x equals 3, and then there's an open point or hole where x equals 3. And then we have the function here, f of x equals x squared plus 1. Well, x squared plus 1 assumes k to be 1. And so where k equals 1, we have this function that does not join up at this point. But if we were to use x squared plus 1, we would have what we call a jump discontinuity. But we're not trying to get a jump discontinuity, we're trying to get no discontinuity. And for no discontinuity to occur, we're going to have to compress this parabola down to something like this, where the parabola, instead of going up before x equals 3, will just join up right here and then proceed in this upward direction. So that's what we're looking for, the value of k that will compress the parabola to come right down to here. So let's go ahead and do the analysis. Okay, for the limit to occur, we have to say the limit as x approaches 3 from the left side of g of x equals the limit as x approaches 3 from the right side of g of x. And for the left side, we're talking about this function here, so substituting in 3 for x, we have negative 3 for x plus 9 equals Well, the right side is going to be this piece here, k times 3 for x squared plus 1. Negative 3 plus 9 on the left side is going to be 6, and 3 squared is 9, so we have 9k plus 1. So 6 equals 9k plus 1. Solving for k, subtract 1 from each side of the equation. We have 5 equals 9k, and dividing by 9, canceling, we have k equals 5/9. So 5/9 is the value of k that we've calculated. If we substitute in for k, is going to make these two pieces join up and therefore have the function be continuous over its entirety. So what we're going to do next is look at the graph of 5/9 x squared plus 1 and see how that matches. Well, here we have x equals 3 again, and we see that we join up to an intersection right here. So again, going from the left, we come on this piece, negative x plus 9. We have the hole here, or open point, but we see the parabola here does fill in, so this point is filled in, and therefore the function is continuous. So therefore we know that k is equal to 5/9. So that's our problem, finding the value of k so a piecewise function is continuous and using vertical compression to do so. Thanks for viewing.